Good morning, students. Hope all of you are well. You have already completed your Unit 1 exam. Hope all of you have given good exam. So, today we are going to discuss our next chapter, that is chapter 3, Energy. It is very important and interesting chapter. So, today our discussion portion is, we are going to discuss Unit 1, Energy and Work and their units. Energy and work and their units. In this chapter, you are going to learn about energy and work. So, normally if we say, what is energy? In single sentence, we can say, ability to do work is called energy. So what we know that ability to do work is called energy. Now, the word energy is commonly used in our daily life. Energy, that word we are using in our daily life normally. Science has given in a definite, it is a definite and precise meaning. Let us consider few examples. So we will explain the following using few examples. First, we are giving example number 1. When a raised hammer hits a nail placed on a piece of wood, it drives the nail into the wood. Next is, when the striker hits the stationary carom coin, it sets the carom coin into motion. So suppose this particular picture you have, this particular thing you have seen, when you are playing a carom board, so you are hitting through a striker. That striker hits the carom coin that is not in motion, that is fixed, stationary. So when it hits, the carom coin start moving. That means it is in motion. So we have many examples also. When a child winds the spring of a toy car and then places it on the floor, the toy car is set into motion. In the above examples, the object acquired the capability of doing work, though different means. So in all the cases, the object acquires the capability, the object will acquire the capability to do the work. So the object having a capability to do the work is said to be possess energy. So the object which does energy loses energy. So if we do any work, whatever the energy we are having, we will lose some energy in our case. At the same time, the object on which work is done gains energy, and where work is done, there it gets energy. So how does it happen? The object having energy exerts force on other object, and in transfers the energy to it. The object which receives energy may do work. Thus to sum of this, we can define as follows: the capacity or the ability of a body to do work is called energy. So the capacity, we can say the capacity or the ability of a body to do the work is called energy. In a way, the total amount of work done by a body numerically equals to its energy. So energy, there according to the law, according to the conservation of law of energy, it will get later, that energy neither be created nor be destroyed. It can change from one form to another. In the whole universe, the total energy remains constant. So whenever we are applying energy, so that energy, we loses our energy from where the object, where is work done, it gains the energy. So total energy remains fixed, total energy remains constant. So energy neither be created nor be destroyed, it can convert from one form to another. Total energy in the universe remains constant. So the total amount of work done by the body numerically equal to its energy. This ability to do work may be either due to motion of the body or its higher position above the ground level. For example, if 100 joule of work is done in moving a body from one place to another, then the energy of the body is 100 joule. So that means if work done to move a body from one place to another place is 100 joule, so the energy of the body how much? 100 joule. Similarly, 100 joule of work is done raised a body above the ground level. So what is the energy level? Energy level also 100 joule. So we can say that in physics, and another thing we can say in physics, what is work? Any physical or mental activity may be regarded as work. In our language, in everybody's language, normally you can say that any physical or mental activity may be regarded as work. For example, a teacher taking a class while standing is doing work, or the student learning while sitting on the benches is also doing work. But all such activities will not fall under heading of work. In physics, work is said to be done when the applied force causes some displacement. Means what force we are applying, there should be some displacement of the object from point A to point B, from one point to another point. So that's why it is called work done. Now, when you are reading, writing or singing, you may say that you are doing mental work. Similarly, if a teacher teaching in a class while standing, he is said to be doing work, mental work, doing mental work. When a girl is cycling, girl is doing physical work. When a laborer carrying some bricks on his head, he is also doing physical work. When a car, bus or train moves, it does mechanical work. Okay, so according to physics, work is said to be done only when applied force causes some displacement of the body. So what force is applied? Based on the force, the particular object will displaced, means they will move from one point to another. Then it is said to be in its own direction, according to the direction of the force. So then it is said to be work has to be done. So here also written, when a force causes displacement in its own direction, work is said to be done. Now, for work done, what were the factors are involved? For work done, what were the factors are involved? We said that work done by a body depends upon the force applied. That is, more on the work done, the more is force applied. So work done normally depends on force applied. So it depends on two things. First, for doing the work, two conditions are necessary. There must be force acting on the body, first is, and the body must be moved in the direction of the force. Now we are explaining through some mathematical deduction. What is given mathematically? We can say that work is said to be done. Work is defined as the product of force and displacement through which force acts. Work is said to be done. Work is defined as the product of force and displacement through which force acts. Suppose if we take F as the applied force, S is the displacement in the direction of the applied force, and W is the work done. If F is the applied force, S is the displacement of the force in the direction of the applied force, and W is the work done, then we can say work done equal to force into displacement through which the force act. So W equal to F into S. W is a work done, W is a work done, F is a force applied, and S is a displacement in the direction of the applied force. So W equal to F into S. So from the above expression, it is clear that if force does not cause any displacement, if this force does not cause any displacement, then what will happen? Then displacement, that means S equal to 0. So what will happen? W equal to F into S equal to F into 0 equal to 0. So we can clearly say that if there is no displacement, then it is said to be no work done. So the work done by the body is 0 in physics. Furthermore, if the displacement causes by a force at a right angle to the direction of the applied force, then it is said to be applied force is applied work done. So work done is 0. So if the displacement caused by a force at right angle to the direction of the applied force, at right angle to the direction of the applied force, at right angle to the direction of the applied force, then it is said to be work done is 0. Consider, suppose I am giving one example for this. Suppose you are carrying your heavy school bag on your shoulders and standing still. The weight of the school bag is acting vertically downwards. To counter this weight, your shoulder apply an equal force in the vertical upward direction. Due to this force, no displacement is caused. Thus, in language of physics, keep in mind, thus in language of physics, you are not doing any work. So, if the applied force is in the direction of right angle to the, if the force applied, displacement caused, if the displacement caused in at right angle in the direction of the applied force, then according to physics it is said to be no work done, or work done is 0. Next is having the work will be done only if you start climbing up the stairs. This is another example given. Now, unit of work. What is the unit of work? We should know. The SI unit of work is joule. See the spelling, small letter Joule. When you write in symbol, it will be capital J. So keep in mind. So the SI unit of work is joule. What is the definition of joule? What do you know? W equal to F into S. So 1 joule equal to what is the unit of force? 1 Newton into displacement 1 meter. So that's what it is written. So when 1 Newton causes a displacement, 1 Newton causes a displacement of 1 meter. 1 Newton causes a displacement in 1 meter of 1 meter in its own direction. Then it is said to be 1 joule. So what is given? When a force of 1 Newton causes a displacement of 1 meter in its own direction, the work done is said to be 1 joule. Now, beside this, calorie is one of the old unit of energy. Calorie is one of the old unit of energy. So what is the definition of calorie? The amount of heat energy required to raise the temperature. The amount of heat energy required to raise the temperature, to increase the temperature of 1 gram of water through 1 degree Celsius. How much? 1 gram of water through 1 degree Celsius is said to be 1 calorie. So unit of calorie of measurement of energy was found to be small. So we can use the multiple of calorie is kilocalorie. So in this case, the amount of heat energy required to raise the temperature of, here we are writing 1 gram of water through 1 degree Celsius. Here 1 kilogram, that means 1000 gram. 1000 gram of water through 1 degree Celsius, it is called kilocalorie. So 1 kilocalorie equal to 1000 calories. 1 kilocalorie equal to 1000 calories. So calorie is the oldest unit of energy. So students, these are the explanation of chapter 1. Please go through the unit 1, chapter 3. These are the explanation of unit 1, chapter 3. Please go through the unit 1 section very well. I hope this explanation will help you to understand the chapter. That's it. Thank you very much. Goodbye.